All right, now I'm going to give you help on comparing a quantitative to a categorical. So we need three things. We need to figure out a box plot, do a one-way ANOVA, and conclude whether or not there's a relationship based on our p-value. So let's go over to StatCrunch again. So this time we're going to do what we did last time in class. I'll just walk through it again. We're going to see if height is influenced by birthplace. I'm choosing birthplace because it has more than two categories, so it can be kind of interesting. So height, birthplace. First thing I want is a box plot, so I can put in what this looks like before. So my quantitative is height. I want to group this by birthplace. And then it's up to me. I can choose any of these. I like outliers. I kind of like my boxes horizontal, but actually maybe for space it might make sense to try them vertical. I can have fun, change the colors, but this is all I really need. Okay, so again, just like last time, it looks like I have some data entry issues. I have a San Diego here without a space and San Diego with a space. And again, this would lose me points. So let's go ahead and fix that before I lose points for it. So I need to figure out where that San Diegan is without the space. Somehow it's this last row again. I don't know how all these end up off in this last row. So anyways, now it should be fixed. I'll redo my graph, my box plot of height, grouping by birthplace. So now I only have 4. California, but not San Diego. Outside the USA, San Diego and USA, but not California. I do not like how small these different labels are becoming when I actually print this. So I might actually go in here. I'm just thinking about, like, if I don't want this to take up my whole slide, but as soon as I do this, it gets really tiny. I don't think there's any way to change my labels so that they don't suck. Just thinking about it. Maybe I can do I don't know how this works, you guys. I should not be doing this, but it's going to happen. So CA, International, US, SD, US. Okay, compute. Does it give me? No, it didn't work. Damn it. All right, I have no idea how to fix that. I could go ahead and relabel these, but I'm just going to maybe actually I have a plan. I'm going to put these back the way they were, a little bit narrower. I'm going to do my snipping tool. Dun, dun, dun. And I'm going to copy this. I'm going to put it into, my slide. So here we go, 11B. This is me again, Kelly. And I'm going to be looking at birthplace and height. It doesn't matter what order I put these in. Okay, so I'm going to move my text box over because I like to have my display first. And I'm going to put my display in here. Okay. So what I might do for this is I might add labels just to make it easier. You don't have to during your presentation. As long as you can tell people what these are, you're fine. But I want to have something here. So California that people could read. This is Humongo. I like my permanent marker font. And I like to make this aggressively red. And then I could even take this and rotate it so that way it doesn't take up quite as much room if I want. So I can take this and move it around. Boop. So now that's labeled more obviously that it's California. And if I want to, I can just copy this. Control C, Control V. Ah, that's not what I wanted to Control C, Control V. I wanted to select the whole thing. Control C, Control V. Haha. Outside US, and I make that a lot longer, and I can label that towards the top. I mean, it doesn't have to be great. I just want something where if I'm showing this in class, people can easily see what each of these things is, and I'm not going to have to do too much of remembering what the heck. Control V. Then we have San Diego. Just make that SD. Drag that over next to my San Diego one. And Control V. Oops, that's not what I want. Control V. USA. And I'll be able to, like, technically this should have a little bit more information, like USA does not include keep moving that on accident. Does not include California and whatnot, but I'll just say that during the actual presentation so I don't worry too much. But now at least I'm thinking ahead towards the presentation. People can actually read that. And unfortunately, I changed that to permanent marker, which doesn't really matter, but whatever. And I don't like the color. very anal retentive about these things. So anyways, now we're going to do ANOVA. So just like on this one, I said what we did. I'm going to do the same thing here. So we ran a single factor or one-way ANOVA. And I should probably put down what my hypotheses were. So for ANOVA, the null hypothesis is that the average height is the same for students, for MESA students from any of the 4 birthplaces. I'll do it this way, SD, CA, USA, non-USA. Alright, HA then is that the average height is different in at least 1 birthplace. There's no reason you need to math it up more. This is perfectly fine. And then we're going to go run our ANOVA. So ANOVA is in stat. Down at ANOVA, we're doing one way. You do need to choose values in a single column, just like I have here. One way ANOVA, values in a single column. And your responses, even if you don't think your quantitative is more the response variable, it has to be as the response. It's just how ANOVA works. And then our categorical variable is going to be in our factors, so birthplace. And that's really all you need. You're going to press compute, and then we're going to get out a p-value. So in this case, there's our output. I'm just going to grab this to put into my slide. Boom. Don't want to take up too much space. Copy. Control V. Make this a little bit smaller. So the one thing that matters the most is really the p-value, although these means are very useful because they can kind of let us see where the taller people are on average. We can see outside the U.S., especially when we look at these bars, outside the U.S. looks much, much shorter than any of the U.S. places, right? And then we have California running the tallest, then San Diego, then the rest of the U.S., and then outside. Which we can see in the box plot, and we can see that again here with our means. Now, looking at our information, we needed at least 5 in each of these categories. We probably don't have a lot of the stuff we needed for ANOVA, but we can make our conclusion now. We got this p-value of 0.08. Now we have 2 options. Since 0.08 is less than 0.1 or 10%, we could say at a 10% level we reject the null. Alternatively, we could use our 0.05, in which case we'd fail to reject. Since we want to be able to report something, I would probably say the smart thing to do here would be to say, okay, well, this is less than 10%. So we're going to reject the null. I'm going to use that 10% cutoff. I know it's not our standard, but it's something I'm allowed to use, and it's going to mean that I can actually say something significant and get to make a conclusion. So I'm going to go with that, and I'm going to insert my text box for my conclusion, because that's the last thing I need. At a 10% significance level, I don't know, level, there is enough evidence to say that the average height differs based on birthplace. Boom. It looks like there's a relationship between average height and birthplace. And this is one I did in class where I got even fancier, and I said, well, I can see based on this, it looks like people born outside the U.S. are just, they happen to be shorter than everyone else. And unfortunately with ANOVA, all I can say is that there's a difference. I can look at these means, I can look at this lovely box plots, and I can say it looks like, right, another note, it looks like people born outside the U.S. are shorter. If I really wanted to prove that statistically, I would need to do something like, let me insert a row, just so you can see how fancy you could get, international. So we'll just make like an international row, and I'm going to sort this. So everybody who is from California is a no for international. Anybody who is from outside the USA is a yes for international. And I'm just Control-C and Control-V to get all these in quickly after that sort. So I could actually make myself a glorious, ooh, I went way too far, new category for whether or not a student is international. And I could say, let me now be able to test. If I have two groups, then I can actually have a direction. So in this case, I could go to stat, tstat with two samples. Come on, you know you want to click two sample, with data. Now here's the one part that makes this a little bit more challenging, is that it thinks we have two different columns, and we only have one column. Height is the same for both columns, but I have to tell it where. So I want the height, and I want to say that I think people who are international, so I'm going to choose international, if that is equal to yes, so it says international equal to yes. So now it's only going to take people's heights where the international is yes, and I'm going to do the same thing here. International equals, oops, I don't need two equals, that's great. No, what did I do? I don't need two equals, that's crazy, so delete that. And I'm going to put in the no. Oops, only once again, I'm being crazy. So now it's basically comparing people whose height, who's international to yes versus no. And I could even say, well, I think the people who say yes are going to be shorter than those that say no. And I could compute that. And now you can see I have a very highly significant p-value. Versus before, I was like, I have to use 10% to get that. And I can make a better conclusion. So if I was going to finish this up and make like another slide, if I was to make slide C, be Kelly again, and let's make this one international student, and height. Again, I would probably move this on over. I would say we ran a 2-sample t-test. And in this case, oops, why does it space things? I hate spaced stuff. Whatever. The null was that the average height of international students is the same. Remember, your null always has to be the same as American students, HA, the average height of international students is less than American students. Boom. And then we could throw in that output that we have there. We got this lovely p-value basically showing this off. So new, grab this crap, throw it, oops, I didn't press copy. That's not what I wanted. Cancel. Oh, I have to resnip it now. Bastards. Cancel. Anyways, you get the idea. And I'd want a new thing. But this output is very statistically significant. I can definitely come here and say, after I put in all that stuff, we can conclude that the average height of international students is less than the average height of U.S. students, of American students, at Mesa College, right? Boom. So that's what it would look like if you went ahead and then had two groups. And you can also do this if you have two groups originally. So if you're not sitting there looking at 4 groups, in which case you have to run ANOVA and you do have a direction, a 2-sample t-test is a good idea. But you will have to do that weird thing that we did of building what the yes and the no are so you can actually have a comparison. So hopefully that helps with categorical versus quantitative.